Okay, question 17. So in this question, the student thinks that he's proved that P plus Q is greater than P when P and Q are negative. And the way that he or she thinks they've done it is by this method. Now, they've started with saying that P plus Q is greater than P. They've squared both sides, which is fine. P plus Q all squared is greater than P squared, if that's true. They've then expanded the bracket P plus Q all squared to give P squared plus 2PQ plus Q squared. Well, that's a valid move. They then said, well, there's a P squared on both sides. I'm going to subtract P squared from both sides, which you can do perfectly fine with an inequality. So that then leaves them with 2PQ plus Q squared is greater than 0, all right? And although they didn't write it, that's what they're kind of referring to now as their conclusion, their sort of final line. They've then gone to think, well, independently, is 2pq plus q squared greater than 0? So they thought, well, if p and q are both negative, then a negative times a negative, so p times q is that would be a negative times a negative. Well, a negative times a negative is positive, times it by 2, you're left with a positive, so 2pq would then be positive, i.e. greater than 0. And if q is negative, then, well, in fact, it doesn't matter if it's negative or positive. A square number is going to be positive, crucially. So if q is not 0, so if q is negative, it's not 0. So a negative number squared will then be positive. So we have a positive in 2pq and a positive in q squared. So a positive plus a positive will certainly be positive, so greater than 0. Hence, we can be sure that if p and q are negative, then 2pq plus q squared is indeed greater than 0. And so by these couple of lines here, we've independently proven that 2p plus q squared is greater than 0, and we're confident about that. Then they've said, well, this is with the sort of the logic from the logical steps I made, this is the conclusion I got to, and we've now independently shown that conclusion is correct. So then he goes on to say, well, since this conclusion is definitely true, the premise must be true, the premise being the one in red. Hence, p plus q is greater than p. Okay. Well, so where have they gone wrong? Well, the premise is just stated in this so-called proof. The one in red here, p plus q is greater than p. Everything else is built on that statement. But the student is trying to prove that statement, and yet they've just stated it to start with and built everything else on it. So then the key mistake is that they have assumed what they're actually trying to prove. They've assumed the premise to be true, done logical steps, which the logical steps themselves may be fine, but then they've ended up going back to say, well, because of all these logical steps we've made, this premise is therefore true. Well, it was assumed to be true in the first place. So, crucially, the mistake made is that the student has assumed the premise to be true. The premise of the statement to be true. So in part B, we're asked to give a counterexample when P and Q are negative to disprove the idea that P plus Q will always be greater than P. Okay, so just choose two very simple negative numbers for P and Q. So let's say P is negative 1 and Q is negative 2. Okay, in that case then, P plus Q would be negative 1 plus negative 2. And plus negative is obviously negative, so negative 1 minus 2, which is minus 3. P itself is minus 1. So P plus Q greater than P would be suggesting that our P plus Q value, which is minus 3, is greater than our P value, which is minus 1. But minus 3 is certainly not greater than minus 1. Minus 3 is even less, more or less than minus 1. 3 might be greater than 1, but minus 3 is lower than minus 1. So that statement then is a contradiction. Okay, and hence we've given our counter example.